Hi, it's Ian from Huge Menace, and in this blended tutorial we're going to create Sci-Fi Greebles using geometry nodes. This approach will provide you with a flexible procedural system that also gives you good control over the art direction. We'll start by defining some design criteria to guide us before we get lost in the noodly world of geometry nodes. Then work on four main functions of the procedural system: grid generation, surface paneling, component placement, and manual placement control. I think a good solution would be resizable, generate random results, but not too random. In CG, it can often be a bit too easy to spot the random noise function at play. So it should have a sense of hierarchy and order, so it seems intentionally designed, despite the fact that it's based on a random number algorithm. And I want it to be modular, so it's easy to add, change, or remove Greebly components. And finally, art directable, so there's some element of manual control. With these ideas in mind, hopefully we can achieve a more intentional design. It's important to note I'm using Blender 4.3, and this is important because we're going to be using some of the new functionality available in geometry nodes. To start with, I'm just going to delete the default light and camera, and I'm going to select the cube and rename it to Greebles. And I like to work in millimeters, so I'm going to change the scene units length to millimeters. You can then head over to the Modify tab. I don't want the smooth modifier, but I am going to add a geometry nodes and click New. I'm going to rename this to Greeble System. All right, let's head over to the geometry nodes workspace. And I don't really want this animation timeline, so I'm going to close that area and then just resize things a bit so we can see a bit more of what we're doing. So I'm going to hold down Control and right click, and I'm going to drag through the connection here to delete that. I'm going to press Shift A and type in grid. And this is going to become the base of our Greeble system that helps us place components. So I want to connect the mesh to the geometry output. And you can see here in the viewport, if I zoom in, we've got a square. This is 1 meter by 1 meter. And that's important because I'm going to decide at this point in time that the largest component in my Greebles will be 1 meter by meter. This grid has 3 vertices, 1, 2, 3 in each direction. And I really want to control the size of this within the system. So I'm going to go ahead and click on the geometry input, press N to open the group information. I'm going to press plus, and I'm going to add a new input to this group and call this size X. And we want that to be an integer, a minimum value of 0, or actually a minimum value of 1. We don't need a maximum. Let's do another one. We'll do another input, size Y, again an integer, and the minimum value will be 1. And then I can just drag the geometry back up above here so it's a bit more organized. Now you can see that reflected on the left in the group input node here. So we could go ahead and drag those straight into the vertices, the size X and size Y. You can see that we've got these values, but they're set to 0 by default. So I should probably also set up those default values of 1. And then just make sure this says 1 and 1, and there you go, our grid is back. Now that's great because it allows us to actually control the size of our grid, but you'll notice that we then get non-uniform faces here. We've got this like wide face where we really want that to remain a square. So what I need to do is take those size inputs. So I'll grab the X first and then let go here. I'm going to add a math node and specifically an add. I'll just zoom out. And I just want to add 1 to this. So I'm going to add 1 and then pipe that into the vertices because there's always one more vertice than the size. I'm going to do exactly the same with the Y. So I'm going to hit Shift D to duplicate this same function, grab the size Y, add 1 to it, and then plug that into the vertices. So now, no matter how big I make this grid, it's always going to have square faces. Now, the next thing I want to do is to subdivide these meter by meter squares. So I'm going to press Shift A, type sub, choose the subdivide mesh operation and drop that in. Now that's great, but I don't want every one of the original faces to be subdivided. So how I can achieve this is I can add a separate geometry node, drop that in, and I'm going to change that to the face selection mode. And you'll notice there's a selection input here. Now, if I drag and drop that, I want a random value. And you can see when I use this, it's producing a Boolean and is, probability of 50% that it will select a face and then subdivide it. Now, I don't want to lose all of the original mesh. I'm going to add a join geometry node, add that in, just reorganize this a little bit, and then take that original mesh and pipe it back over here. Now we've got the subdivided faces, and we've got the original mesh joined back together. And what I'm trying to achieve here is this sort of effect where some of these faces remain the meter by meter, and some of them get divided down into smaller and smaller pieces. And this will end up achieving a kind of clustering of detail in some areas. And it also will achieve, big, medium, and small shapes. So we establish a nice form language and a sense of order rather than just complete randomness. Now, we've subdivided our squares once, but we really want to be able to subdivide them multiple times. But I can't just go ahead and increase the levels because we just end up subdividing our existing squares into smaller pieces. So to be able to repeat this process, I actually want to take these nodes, the separate geometry, subdivide mesh, join geometry, and also the random value here, and turn this into a group. So we press Control G. That groups these nodes, and we can now reuse these nodes multiple times so that we can get multiple levels of subdivision. Now, I want to rename this node group. I'm going to call this subdivide random faces. And then we can go and jump back up to the main node network, and we've got our little utility here to randomly select some faces and then subdivide them. Now I want to subdivide multiple times so that we have big, medium, and small. Now we could just duplicate this subdivide random faces utility group we've made. So press Shift D, then drop that in. And I could keep duplicating and adding this to the node network to get further levels of subdivision. Now that's achieving roughly the result I want, where I've got large, medium, and smaller, and then smaller again squares, but it's not a particularly elegant solution. And there's a better way to do this. So I'll just undo that, add a repeat zone. So press Shift A and type in repeat. The repeat utility basically lets you repeat an operation multiple times. So if we take the original grid mesh, plug it in, I'm just going to disconnect the subdivide random utility here. I'm going to take this and drop that inside the repeat zone. And this is going to be repeated a number of times or a number of iterations. Make sure I connect that to our group output. Now, each time you add an iteration, you can see that it is subdividing the mesh further and further. And you get this really interesting clustering of detail where you get these larger shapes, these larger squares, some medium, some small, and instead of it being kind of completely evenly distributed, you do get this large to small distribution of clustering that's going to make our Greebles look particularly techy and interesting and kind of visually balanced. If you're familiar with programming, you'll know that this is a recursive operation. Now, I want to make sure I've got control of how many levels at a top level. So I'm going to take that iteration input on the repeat and plug it into our group input to make sure that we've got control over the number of subdivisions from the top level. I also want to be able to control the probability of when these squares are actually subdivided, and I want to change the random seed, but these are both tucked inside this subdivide random faces utility. So I need to do a couple of things. The first thing I want to do is go into this group, and I want to make sure that I plug the probability into the group input node and the seed, the random seed. And now if I go back up to the main node network, I've got those input parameters available. go ahead and wire that probability into the group input of the top level and the seed as well. Now we can control the probability of subdivision. So we can have a few or we can have many. And if we don't like any particular result, we can just flick through the random seed to get different results until we find something we really like. Later on, I'm going to want to place modular Greebles onto these different subdivided squares based on how large that square is. I want to make sure that I have, some large squares. I'm going to call this level 0. I want to make sure I have some medium size squares, level 1. And then some slightly smaller, I'm going to call these level 2. Smaller again, level 3. And then these really tiny squares, I'm going to call level 4. But we need some way of determining what size each one of these faces in order to be able to choose the appropriate sized asset, the Greeble, to then actually put onto these faces. But that doesn't exist in the geometry right now. We don't have any way of telling what size each of these faces is. Let's return to geometry nodes and take a look at the spreadsheet. Now, by default, our mesh has different components. We have vertices, edges, faces, and face corners. And there are 274 vertices. And you can see here in the spreadsheet, it tells us information about the data that Blender is storing in relation to this mesh. In this case, counting from 0 all the way up to 273, that gives us 274 vertices in total. And each one of those vertices has this ID, this number on the left, and then it has a position attribute. Now that's a default attribute that has an X, Y, and Z component. And this spreadsheet view helps us understand the data. And in our case, it'd be great if we could store, maybe on the faces here, a custom attribute that lets us understand what particular size each of these faces is. So it'd be great if I could store a custom attribute on each face. To do this, we're going to go back into the subdivide random faces utility group that we created. And I'll just do a little bit of reorganizing. I'm going to move the random value down here, move the separate geometry over here, make a little bit of space. And what I want to do is add Shift A store named attribute node. Now, this node will store a custom named attribute. Now I want to store an integer. I want to store it on the face domain. And I want to call this level. As soon as I do that, you'll see in the geometry nodes spreadsheet that the faces now get this new attribute, this new custom attribute, and that defaults to a value of 0. Fantastic. So we've got a stored named attribute called level, but it's not exactly right because we want to make sure that it increments every time the mesh is subdivided. So to do that, what we're going to need to do is retrieve that stored attribute. Remember, this is happening in a repeating loop. So press Shift A, I search for named attribute. Again, it's an integer and it's called level. And every time we go through to actually subdivide the mesh, we want to retrieve this attribute. Then we want to grab a math node and increment it. So we're going to take the value, we're going to add 1, oops, sorry, messed up, and then plug that into the value. Now you'll see in the geometry spreadsheet that we've got level 4. That makes sense. That's how many times, how many iterations we're subdividing this mesh by. And if I scroll down, you can see 3, 2, and 1s and 0s. Great. So now we're storing a named attribute called level on each of the faces, but it's not very handy trying to view this in the spreadsheet. It'd be nice if we could view it on the mesh itself in the viewport and confirm that we've got everything right. So let's go back up to the main node network. And just before the group output, I want to press Shift A and add a viewer node. I want to plug in my geometry to this. And you can toggle it on and off using the visibility toggle here. We want it turned on. I press Shift A and I want to again retrieve that named attribute. So I'm going to grab the named attribute node, plug it into the value. The viewport turns black. We'll fix that in a moment. Again, we want to choose integer. We want to find our custom attribute called level. And now we want to go into our viewport, into the viewport overlays, viewer node options, turn off the color opacity, and turn on the attribute text. Great. So it looks like we've got our level custom attribute displaying on each face. Fantastic. But I'm glad I did this because I'm noticing a problem. Here's a pretty good example. It seems like there's this zero, level 0, and there's a level 1 appearing kind of on the vertex. So there's clearly something wrong. In this case, what it's doing is showing us, I think, the previous subdivision that occurred, because you originally would have started with a level 0 in this position and then subdivided level 1. And you can see here there would have been a level 1 here before it got subdivided into level 2. So there's clearly something wrong. And the viewer node is incredibly useful for helping us to debug problems like this. Turns out I made a bit of a mistake in the subdivide random faces utility. So let's go back into that. The mistake that I've made is I've taken the group input and joined it with the subdivided faces back together. But what I really wanted to do, if I just cut this, is I actually wanted to separate the geometry and then subdivide it, store our named attribute called level, and then join it back to the existing mesh. But I want to exclude the selection, so I choose the inverted here and I plug that in. So I'll just reorganize here. So now I'm taking my grid, I'm separating it by face, subdividing it, storing a named attribute, and then joining it back to the unseparated pieces, so the original pieces of the mesh. So now if we go back up into the main node network, toggle the viewer node back on, we can see we've fixed our problem. We've got level 1, level 2, I can see level 0 here, level 3 and level 4. So that all looks correct. And the viewer node is incredibly useful for debugging problems like this. Let's do a little bit of tidy up before we move on to the next step. So select all of your nodes and then press Control J to frame and group those. And then if you go into the node panel here, you can give that a name. So I'm going to call this grid generation. Great, that just helps keep things organized. I also want to tidy up these connections here. I don't love the way that they overlap, so it's totally fine in this scenario to just duplicate the group input node. I'll just disconnect these two and just connect them from here instead so that it looks a little bit cleaner overall. And you can do some tidying up too if you want. I also want to make sure that in the group input that I give these labels slightly better names. So in the case of the probability, this is really the subdivision probability. And we may as well call this random seed to make it completely clear what that is as well. Now that we've created our grid generator, I want to talk about surface paneling. So I'm going to jump across to the layout view for a moment. And you can see that I've organized this Greebles into a main collection. I'm going to hide that for a moment. And then I'm going to enable this modules collection. Now I've gone ahead and modeled a bunch of panels. So here's a very simple example. It's got a flat plane and then another plane that's extruded and a tiny little vertex bevel on the corner. And I've used our free plugin for Blender called ND to model these. If I expand this modules collection, you can see there's a base, which is going to be our surface panels, and a components. We'll look at that later. If I expand the base, you can see here I've got a number of collections from level 0 all the way down to level 4. And those each represent the different scale panels for the different sized faces. So if I look in the base L0, you can see I've actually got 2 collections in here, and each of these collections has some geometry in it. And if I flick through and look at the second one here, you can see this is a different variation, has a little semicircular notch, 4 of them out of the top of the surface. And that's going to be important because it's going to allow us to achieve a bit more variation in our surface paneling. If I look at the next level down, level 1, You can see I've made 4, a very simple one with 2 notches, one with a straight and angular kind of seam, and then one with a straight seam. And basically we want to be instancing the correct size, for example, level 1, and then randomly selecting from these particular variations so that we have this nice, interesting and varied result in our surface paneling on top of our grid. So let's just hide this, turn that off, and select our Greebles and turn on that collection, and we'll head back to geometry nodes. We're going to use this grid generator to effectively be the foundation of our system here, and we're going to start instancing those panels onto the appropriately sized face. To start with, I'm just going to disable the viewer node, and I want to make sure this group output is outside of this frame. So I'm going to right click and say remove from frame, and then just move it over to the right hand side here. Press Shift A, and let's add a mesh 2 points node and connect that in. That's going to create a point on every vertice, but we want to switch to faces. And now we have a point at the center of each of our faces from our grid. And we're going to instance the panels onto these points. So press Shift A and search for instance on points. And just for the sake of testing, we're going to add a cube and drop that in. And I'll just scale those down to say 50. You can see that this is instance a cube on every single one of those points, but this is a very simple setup. What we actually want to do in our case is within our modules collection here, we've got these base panels, and depending on the level of each of the faces, we want to first choose this collection, say base level 0, and then we want to instance randomly one of these variations. So let's just delete the cube here. We're going to go ahead and make a bit more space for myself, and I'm going to just remove the connection here and move the instance to points out of the way. Press Shift A, and we want to use a for each element utility. I'm going to plug the points into the geometry input. I'm just going to make this a bit bigger. And we want to take, if we wanted the original points to come through, we would choose this upper connection, but we actually want the generated geometry, which we're going to do, the instances we're going to create instead. So we plug that into the group output. I'm going to grab my instance to points. Now for each element, so for each point, I want to then be instancing something and putting it into this geometry output. Now, in our case, we want to do this based on the level of each of the faces. So if I press Shift A and search for named attribute, I'm going to pop this outside the for each zone, and it's of type integer called level. I want to plug this attribute into the blank input here on the for each element. So what this is going to do basically is for each point, it's going to pass in this level attribute, and then we're going to be able to use that level attribute for that specific point to choose a particular collection and then instance it. So let's do Shift A and search for index switch. And I'm going to just drop this in here. We want to take the level attribute and plug it into the index. So that's the thing we're going to be determining which collection to choose. So depending on the level, we're going to choose a particular collection. So we want to change this from geometry to collection, and then go ahead and start adding base L0, base L1, and we need more inputs. So if I open the node info panel, I can add 3 more. Close that again. Base L2, 3, and 4. So this is going to allow us to switch between the collections based on the level attribute. The next thing we need to do is get a collection info node, plug that in, and then take the instance output into the instance input of the instance on points. And there you go, we're getting some results. Now, it's a little bit funky because we also need to make sure we've got separate children turned on and reset children. And we also need to make sure we've got pick instance enabled. Let's make a bit more space for ourselves now. So this is pretty awesome. It's actually, if I switch into layout view, it's actually instancing each of our panels from our collections based on the size of the original face. Level 0, level 1, level 2, level 3, and even some really small level 4 ones here. Okay, so how do we choose between the different variants for each of these base sizes? Well, we can do that with a random value. So Shift A, random value, and we're going to choose an integer here, and we're going to plug this into the instance index. Now, immediately you'll see a change where we're starting to see some variations, but we have a problem here because the different collections have a different number of variants. So base L0 has 2, whereas base L1 has 4. And so we want a different maximum value so that we're choosing the appropriate random range to select the right instances. Now, to do that, we can actually inspect the collection and find out how many sub-collections it has, either 2 or 4 in these two examples. So if we drag out from here and we look for domain, domain size inspects the instances, and if we choose this instances option here, we get the instance count. And if I plug that into maximum, now it's going to be selecting correctly from the maximum number of variants within each collection. But we're not quite seeing the right thing here, and that's because in the for each element loop, we're basically getting the same random seed every time. And so we're not getting kind of a nice result. Now, if I flick through to a different seed, you should see occasionally, yep, there you go, it's changing the output. But that's pretty unreliable. So how else can we deal with this? Well, luckily we've got this ID input. And if we take the index of the for each element, which represents the kind of individual index of each point, then we get a unique number that we can plug into this ID. And as a result, the random value will be different for each element. So now you can see some of the large panels are completely flat. Some of them have these notches taken out. You can see also that the level 1 have different variations as well, and it seems to all be working correctly. Let's make sure our instances also have a random rotation. Now, the rotation input on instance to point does take degrees as an input, but we only want to affect the Z, and to do that, we have to use combine XYZ. Now, combine XYZ is a vector, which means we're no longer using degrees, we'd be using radians. So we have to keep that in mind as we're building this random rotation. Now, we only want to affect the Z, and let's just start by putting in a random value. Now, the question is, what do we do here? If we're using radians, we want it to go from 0, so no rotation, to 360. Now, if you enter TAU, which stands for tau, that's actually pi times 2, which effectively equals 360. But we don't just want this to end up at any random angle. We actually want this to end up on 90-degree increments. So I'm going to add a math node, and I'm going to choose the snap function. And we want a quarter of a rotation, which would be pi divided by 2. If we change the random seed, you should see these all take on a random rotation. And that's great, that works, but I don't know about you, but if I was to share this file with somebody else or come back to this later, I might forget why these numbers are so specific. So it's probably better off if we use a 2 radians function. So in the math nodes, you can choose a 2 radians conversion. Type in the degrees, in this case 90 degrees, and then plug that guy into the increment. If you hover over the output here, you'll see it's the same number. It's just pi divided by 2. We're going to duplicate this node, plug it into the maximum, and change this to 360. It's a bit more readable, but at least now you know the shorthand if you want to use it. This random rotation function is so useful, I think we should make it a group. And in fact, we'll be using this later on when we place our components. We want them to have random rotation too. So select these nodes and then press Ctrl G. And we're going to press N to open the node information panel, go to the group, and we're going to call this random 90 degrees. Great. Now there's one more detail here that I want to address, and that is that the random seed here is going to be the same unless we change it. Now there's a couple of ways to change that. You can, of course, input a random seed, but because we're using our for each element outside, I'm actually going to plug the ID of the random value in to the group input so that we've got that now available. Going back up a level, we've got that now available as an input on our little utility function. And just like we used the index from the for each element for the random value here on the instance, I'm going to plug that index into the ID. Now our random 90-degree rotation is receiving a different index number for each element, and you'll notice that the elements now have a different rotation. So this level 1 panel has these notches on this end, and this one has it on the lower end. If we didn't do that, if I just get rid of the ID here for a second, you'll notice that these seem to have a similar rotation. Plug it back in, and you'll notice that it's unique for each one. Finally, let's just do a little bit of cleanup here. All of these nodes that we've worked on here up to the end of the for each element, we can now press Ctrl J, join into a frame, and I'm going to click on the node information here and call this surface paneling. That just keeps us nice and tidy so that we know what functions we're dealing with here in this group. Great. We've made a nice randomized surface paneling system, and you can see here it produces some pretty great results that look like it's been intentionally designed, but has obviously underlying randomness to it. And the great thing is we can easily change the scale of this. We can change how often it's subdivided. And of course, if we're not happy with the result, we can go through and change that. Our approach to adding components is pretty much the same as a surface paneling with a couple of small differences. But we can go ahead and duplicate this whole group. Press Shift D, and let's just move that up a little bit. And I'm going to make sure I rename that to component placement. And we want to make sure we plug in the output of our grid generation into the mesh input of the mesh to points on the component placement. And we also want to join the geometry together in front of the group output. So we'll take the generated geometry output here of the component placement and plug that in. Now, right now, that's doing exactly the same thing as the node network below, but we will now update this with the components instead. Earlier on, I also imported some components, level 0 to level 4, and I'm simply going to drag these to update the index switch collection. Make sure each of these are updated. And you can see that they're all spawning in, and it's pretty busy in there right now. And one of the problems is that some of these components either go right to the very edge, or in the case of this particular panel, it's actually a bit too large. What we want to do here is control the scale. Now, I'm just going to add a value node, just something we can easily drive. And I want it to be a uniform scale, so it affects all values, and then just changes to 0.9. But we have a bit of a problem here, and that's that there's really too many components being spawned. So we need some way of controlling how many are actually appearing. To control the density of the component placement, we're going to zoom in here a bit, and we can use the selection property or input of the instance on points. If I drag out here, I'm going to plug in a random value. Now that has a similar problem to our other random values. So we'll take the index and plug that in. And now you can see we've got sort of a 50% probability that a component will be placed. And we can, of course, change that probability to get a dense or less dense result. Great. Okay. So we can change the probability here, but it'd be really good if we could do this from the top level. So let's go ahead and press Shift A and add a group input node. And we're going to go and plug the probability in there. And with the node selected, press N and make sure that we go to the group and just rename this to component probability. So now we can control the subdivision probability, so how densely subdivided it is. But we can also control the component probability, how densely packed it is with these Greebles. There is one tiny little detail that I'm noticing here. If I zoom in, I can see that my components are just intersecting these panels a little bit. Now, luckily, I've modeled this in a way that each of these panels is a standard height. So if we jump back into geometry nodes and we just focus in here so we can see what we're doing. The very last step that we need to do here is just take all these elements and transform them. So I'm going to put a transform geometry node here. And we're just going to shift this up on the Z 10 millimeters. And there we go. That's fixed that little issue. We've come up with a pretty good system here, but it's based on a random number algorithm. So we don't have full control over every detail. What if I wanted to change this component here, or perhaps even place a larger component or object that becomes the focus of my scene? Or maybe I just want to put a pipe that spans multiple squares. And basically, we're going to run into a problem there because we've got these components in the way and we don't really want them looking all ugly and intersecting each other. So we want some sense of manual control. I'm going to go ahead and add a cylinder. And let's just adjust that. I want to make that a bit thinner. I want to rotate that so it's lying down on the surface, make it a bit longer. And then I'll just maybe move it up a bit as well. So you can see here it's intersecting this kind of grill-like component. And we want to make sure that that doesn't occur. So how do we turn off these components and get them out of the way when we've got a manually placed object like this? Well, I'm going to add this to a collection first, and then we'll head over to geometry nodes. So I'm going to right click. I'm going to add to collection. I'm going to make a new collection called manual placement. And I'm going to make sure that whenever I want to manually place an object and I want to make sure that the components don't intersect it, that I place it in this collection. So this collection is going to be the reference. Any object inside it is going to help prevent a component from spawning. Let's head back to geometry nodes. And I'll do a tiny bit of tidy up first. I really want my group input to be inside this frame, so I'll just move that up. And right now, the components are being placed depending on a selection. So what we have here is I think it's a 25% probability that an instance will be placed on each of the points. But we want some kind of way of manually overriding this. So let's go Shift A, and we're going to add a switch node. I want that to be a Boolean, and I'm going to plug this value into true, and then the output into the selection. That's because when this switch is true, we want this value to flow through and allow the instance to be placed on a point. That's great, but I'd like to be able to control this manual switch based on the distance between my manually placed objects and my components. Luckily, there's a node for that. Press Shift A and search for proximity. And this node takes in some geometry. In our case, we want the pipe, and it compares it to the position of something else. So I'm going to grab the manual placement collection and drop that in. We want to make sure that if we add more than one object, say we have multiple pipes or a variety of different manually placed objects, that they're treated as separate children. Now, the instance that comes out of here is not very useful for geometry proximity, so we're going to realize those so that they're actual geometry. And we're going to plug that into the geometry input. Now I want to understand how this node works. So I need to use a viewer node. I'm going to add in the viewer node now. And this viewer node takes some geometry. In this case, I'm going to try and visualize this on the points that we use to place components. And I'm going to plug in the distance parameter from geometry proximity and then turn on the visualization so I can see what's happening. So it looks like we've got numbers here that seem to range from quite small values here. We've got 0.02 right next to the pipe, all the way up to at the edges here, I've got 2.2. And so this is clearly working. It's measuring the distance between these points and our pipe. Now I want to move the pipe and just check that this does indeed work. So I'm just going to lock or pin the geometry nodes view and grab my pipe and just move it around. And we can see that these values are changing. So when I move this over to this side, you can see that all of these points here are being measured towards it, and it's a much lower value now, 0.085. And the numbers that we looked at in the center here, now that's 2.08. So that's changing based on how close we are to the pipe. I'll just undo that. So that's great, but I want to use these numbers to control whether an instance should be spawned or not. So I really want that to be either a 1, saying it's okay, spawn an instance, or if it's near enough to the pipe, I want it to be a 0. So we're going to press Shift A, and we're going to put down a math node again. And I'm going to add that here to the distance output. I'm going to change that to a snap. And you can already see that it's now snapping by default. You can see right next to the pipe, it's 0, and then 0.5, and then 1, and then 1.5 and 2. I'm going to change that to 1. So now it's either off or it's on. And in this case, it goes all the way up to 2. I only want that to be 0 or 1. So I'm going to add in a map range node. Drop that in. That ensures that the output is either a 0 or a 1. And you can now see that if I move the pipe, that we're getting 0 where we don't want an instance to be spawned, and we're getting a 1 further away. But it would be really nice if I could control the sort of range between when a component is placed and when it's not. And that's exactly what map range can help us do. So you'll see here, if I change the from max, that we can actually tweak those numbers. It might be a little bit difficult to see, but we can change how close to the pipe we get a 1 and still remain 0, really close to the pipe. So we can tweak this value to affect the proximity and where we're actually placing components. I'm going to set this to 0.5, so it's pretty close and tied in next to the pipe. And then we don't need our viewer node anymore. So I'm going to plug this value into the switch. And if we grab our pipe and move it around, you'll see that it doesn't allow the components to be spawned when it's present, but everywhere else it's allowing those components to spawn. Fantastic. And that's how you set up manual placement control to ensure that you've got a bit of art directability to your scene. Let's do a little bit of tidy up. I want to grab these nodes. I'm going to Control J to join them, press N, and we're going to label this group manual placement control. I've just done that in the wrong place. So I'm just going to cut that out there. I meant to do that on the node and in the label field. Great. There's just one little extra bit of tidy up I'd like to do here. I think it'd be great if we could control this proximity from the top level. So I'm just going to move this up a little bit. And I'm going to press Shift A and add a group input. Drop that inside the box here. And I want to plug the from max into this blank input here. Select the group input node, go to the group information tab, and we're just going to rename this to proximity. Okay, so now if we jump back into the layout view, we've got our manually placed object. We can move that around and we can make sure that no components spawn when it's in the way. And with our geometry node selected, we can change the proximity. So we can increase it so that there's a wider gap, or narrow it right down. And if we go a bit too low, we'll start to see some of those elements, so its instances actually intersecting. So I'm going to leave this at maybe 0.25. And that's the basis of the overall system and manual placement control. That was a lot of noodling around, so thanks for sticking to the end. I really enjoyed making this little sci-fi scene and sharing these techniques. I hope this was helpful, and if you'd like to see more videos like this, please like and subscribe, and consider joining our Discord. I'd really love to see what kinds of Greebly fun you can come up with. See you next time.